Hello, and welcome to this first session on the language of algebra. Okay? Now, algebra, first of all, is a very, very important part of everyday mathematics. Okay? Today, we are going to begin this path by taking a look at the basic variables within algebra. Now, first of all, we have to try and define what exactly a variable is. Okay? Now, a variable is any letter that is used to represent or take the place of one or more numbers. Okay? Now, the numbers are the values of that variable. Okay? And in turn, a variable expression is a collection of numbers, variables, and operations. Okay? So, for example, if we have the variable expression 8y, okay, we know that this basically means 8 times y, okay? Now, the operation being used here is multiplication, of course, alright? Now, if we have 16 over b, alright, that would be 16 divided by b, and the operation being used there is apparently division, okay? So, basically, that is what a variable expression is. Now, if you look at the expression 8y, okay, I have seen many students go and do this for multiplication, okay? They try and use that x as a multiplication sign, okay? You need to stop doing this right now, okay? Don't do that anymore, because this can confuse others with the variable x, okay? So that'll look like 8xy, all right? You do not want that. So from now on, what you need to do is either put the two together, like 8y, okay? Put parentheses around them, put a dot, okay? I can't really make a dot here. There you go. All right, something to indicate multiplication, but you do not want to make that x, okay? That is bad. Don't do that. Now, replacing each variable in an expression by a number is called evaluating the expression, and the resulting number is the value of that expression. Okay? Now, we have three particular steps in the way that we evaluate a variable expression. Okay? Our first step is to write the variable expression. Okay? Then we substitute our values for variables. Okay? And finally, we simplify the numerical expression. All right, that is all you do for evaluating the expression. Okay, so let's use our good old 8y again. Okay, we've already done step one right now. Okay, 8y, write the variable expression. That's it. Okay, now let's try and evaluate that expression when y equals 2. Okay, well, let's try that out. Okay, substitute our values for variables. We have 8 times 2. Alright, simple equation there. Now what we want to do is finally simplify that numerical expression. 8 times 2 being 16. Okay, and that is basically how you evaluate a variable expression. Okay, not that difficult. Alright, let's try out another one. Okay. Now, average speed is given by this following formula. Okay? Average speed equals distance over time, or basically A equals D over T. Okay? However you would like to write it. Now, what we are going to do is apply this to a real-life problem. Okay? So, we want to find the average speed in miles per hour, mind you, okay? Miles per hour, of a car that traveled 180 miles from, we'll say, Boise, Idaho, okay, to the Minidoka National Wildlife Refuge in approximately 3 hours. Okay, how are we going to solve this? Okay, well, we use the same way or formula that we use to evaluate 8y over there. Okay, first we write our variable expression. Okay, and we've already done that. Average speed equals distance over time. Okay. We substitute our values for variables, okay, the distance in this case being 180 and the time being 3 hours. Okay? We simplify our numerical expression, 180 divided by 3, we get the average speed being 60 miles per hour. Okay? Never, ever, 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 ever forget that unit there. Okay? If you forget a unit in algebra, you're probably going to miss a point or two. Okay? So we can conclude from this that the average speed was 60 miles per hour. Alright, that was simple enough. Now, we're going to do even simpler. Okay? We're going to try to evaluate a geometric expression. Okay? Now, you should know this, okay, but if you don't, that's alright. Now, the perimeter of a triangle is equal to the sum of the lengths of its sides. Okay? In this case, perimeter equals A plus B plus C. Okay? So what we are going to do is find the perimeter of a particular triangle, and its dimensions will be in feet. Okay? Okay, so we have side A here, which equals 8, side B equals 15, and side C equals 17. Alright? Well, we simply use our way to evaluate a variable expression. Okay? First step's already finished. We've already written our variable expression. Perimeter equals A plus B plus C. Okay? Now we want to substitute in those variables. So A we said was 8, B is 15, and C is 17. Okay? Simplify the numerical expression. Okay? 8 plus 15 is 23, plus 17 will give you a total of 40. Okay? So the triangle has perimeter of 40, remember, feet. Okay? Always remember that unit. Right? Unit, unit, unit. So the triangle has perimeter of 40 feet. Simple problem. Okay. Let's take it a step further and apply it with actual money. Now, the simple interest earned by money P, which is called the principal, at an annual interest rate R for T years is given by the formula PRT. Okay? So let's say that you deposit $650, okay, at a rate of 8% per year. Okay? How much simple interest will you earn after 1/2 of a year? Okay? Well, how do we do this here? This time we are dealing with different types of numbers. We are dealing with whole numbers, percentages, and decimals. Right? So, first of all, we are going to write our variable expression. Simple interest equals PRT. Okay? Principal times rate times years. Okay? Now, we substitute our values for variables. Our principal, okay, will be $650. Our rate, now that isn't a percentage, okay, but just to make this a little bit simpler, we're going to put that into a decimal form. So that will be 0.08, okay, and then times the 0.5 for 1/2 of the year. Okay. We simplify the numerical expression, multiply all of that together. Okay, give you a minute for that. And the answer is 26. Okay. So we conclude that after 1/2 of the year, you will have $26 of simple interest. Right? And that is basically how you evaluate a variable expression. Alright, enough of that. I think I've lodged enough of that into your brain already. Let's move on to our second goal and try to model a real-life situation. Now, writing the units of each variable in a real-life problem helps you determine the units for the answer. And this is called unit analysis, and is often used in problem solving in science. Basically, when the same units of measure occur in the numerator and the denominator of an expression, you can simply cancel the units, and you'll be doing this a lot throughout your mathematical career. Now, in real-life problems, you may need to translate words into mathematics. One way to do this is to use a verbal model. Okay? So let's say that you plan to go hiking in the Jedediah Smith Redwood State Park in California. You estimate that you'll hike at a rate of 2 miles per hour on a steep trail, and the round-trip distance is about 7.4 miles. We want to know how long will it take you to hike from Howland Hill Road along the Boy Scout tree trail and back. Okay? Well, what do we do here? Okay? Well, if we remember, we are hiking at a rate of 2 miles per hour, right? And we said the round trip distance is about 7.4 miles. Okay? Well, how long will it take you? Okay? Thus, we are trying to find our time. We go back to our average speed. All right? We are looking at time equals distance over rate for our verbal model. Okay? We have all of our labels here. Okay, 2 miles per hour, 7.4 miles, and we'll use t for time. Okay? Now, we plug those in. T equals 7.4 over 2. Okay? 7.4 divided by 2, we see, simplifying the numerical expression, is 3.7. Thus, it should take you about 3.7 hours to hike the Boy Scout tree trail. Right? Now, let's back up a minute here. Okay? How do we know that hours are the actual correct units of that solution? Well, what we're going to do here is use unit analysis to check that hours are the units of that particular solution. Okay? So, we're going to walk through this step by step here. Alright? We take our original equation of time equals distance over rate. Alright? And we break that up even further. Okay? Our distance, we said, is in miles per hour. Alright? And, or no, excuse me. Our distance is in miles. Okay? And our rate is in miles per hour. Okay, please ignore that. Now, what do we have here? Okay? We have 2 miles here, right? So what do? If they're both in the numerator and the denominator, we have to cancel them. Okay? So you cancel them out, all right? The miles is gone, all right? And we are finally left with hours. Okay? And we can clearly see that these are the correct units of that particular solution. And that is all that I have for you today. So, thank you very much for listening to this little presentation here, and I hope you can view my other videos as well. So, thank you and goodbye.